All right, hi there. This is future me that have some knowledge about what I kind of forgot to show you how to implement in the last part of the video. It's not only enough to actually do these things. We have done our draw call, and everything should be fine. We have actually done this also, but I forgot that um, um, not only do we have to make draw calls, we also have to define the actual screen in DirectX. And we do that by defining a so-called viewport, which is, a viewport. It's a definition on how big the screen is in pixels, where it's located, and so forth. And then we do something like something that is called a scissor, which is actually like using a cutting tool to cut out a piece of the screen that we actually want to render to. Since we will be wanting to show our entire screen, we of course define the scissor as the same as our entire screen. So this means that our renderer API needs to store two components. It needs to store a D3D viewport here, and it also needs to store a D3D12 scissor rect, which is just a rect, meaning a square defined by some bounds. Not only do we need to initialize them during our initialization step here, we also need to bind them to our draw call. You can do different scissor rects and different viewports, but yeah, we will define the top left X and Y position. Then we will define the viewport width and height, which will just be our entire rendering screen space. So since we store our width and height in our member variables, we just use those values. But we also need to store something about our minimum and maximum depth. And we will simply map that to our depth buffer range in DirectX. We do depths between 0 and 1 in Vulkan and OpenGL. There are different ways of defining the depth. I even think they are inverted from DirectX 12, or rather just DirectX in general. Then we define our scissor rect, meaning how much of the viewport we actually want to cut out and do rendering to. And we will simply specify our whole viewport. And we will do the last part of it here. Height. There we go. Okay, now we've initialized our viewport and scissor rect. We need to bind it. Usually you do that after the output merger binding. So we do it by using the graphics command list and record a command to set the viewport. So we have one viewport and we have our viewport defined here, but we would need to provide the address of the struct. We also bind our scissor rect and also give it the address of the struct. And we should be able to now do drawings to our entire screen. So let's see, does everything work? Everything works. I did some debugging trying to remember whatever might be wrong. So let me just show you the current pipeline state. I might have changed values. I probably haven't. I just did some debugging and wrote out the depth states a little more clearly, but it's basically the same as previous episodes. I did change the call mode to none so that we don't care about front face or front or back calling right now. But that's probably the only changes. The shaders didn't change themselves. So yeah, we now have our first triangle. Everything is great. So this is simply the video about doing draw calls. I think we're done with this video, and we will be discussing what to do next. I will do this on the live stream. So I will of course do an introduction in terms of what we're planning to do. I've promised that I will be going into 3D drawing, so we will probably take steps to do 3D drawing. Yeah, we could animate the triangle and so forth, but I'm not sure that's I'm not sure that is that interesting. So yeah, maybe we will just try to focus on getting 3D rendering going. But yeah, that's it for this episode. Thanks for tuning in. Feel free to comment, like, or subscribe. I'll make sure that the GitHub repo is updated in terms of this code that you see that is able to actually render a triangle. All right, take care. See you in the next one. Bye bye.